Greetings, Chem 1 students. This is Mr. Braun, and this is our pre-lab discussion of computer lab number 13 of Chemistry with Vernier, talking about properties of solutions, electrolytes, and non-electrolytes. In this experiment, folks, we are going to be using a conductivity probe. When the probe is placed in a solution that contains ions, it is able to conduct electricity. Therefore, an electrical current is completed across the electrodes, and we have a reading on our conductivity. Now, when we talk about this conductivity, the size of the conductivity value depends on the ability of the aqueous solution to conduct electricity. So, can that solution conduct electricity? If it does, we have a conductivity value. Strong electrolytes give large numbers of ions, therefore they have high conductivity values. Weak electrolytes have smaller amounts of ions, resulting in lower conductivity values. And finally, non-electrolytes don't have ions. Therefore, there is no conductivity. When we talk about this lab, we're going to talk about three different types of compounds. Those are ionic compounds, molecular compounds, and molecular acids. Ionic compounds are the first one. These are usually strong electrolytes, and they can be expected to 100% dissociate in aqueous solutions. Well, what does that mean, dissociate? Well, that is to split into separate smaller atoms, ions, or molecules. In this case, they're going to be splitting into separate smaller ions because it's an ionic compound. Now, I have three examples that we're going to give you. Here is the first one. Sodium nitrate as a solid will dissociate into aqueous sodium ions and aqueous nitrate ions. Here is calcium nitrate. Now notice, when the calcium nitrate dissociates, we have the calcium ion in aqueous solution, but we have two of the nitrate ions in an aqueous solution. Okay. The third one is, let me move this a bit, the third one is iron 3 nitrate. Now once again, notice the iron 3 ion, but we have three of the nitrate ions in aqueous solution. So 1 plus, 1 minus, 2 plus, 2 of them of 1 minus equals 2 minus, 3 plus, 3 of them, 3 minus. So these numbers of nitrates are going to come into play in this lab, as you're going to see later on. Molecular compounds are usually non-electrolytes, which means they will not dissociate into ions, thus resulting in solutions that do not conduct electricity. So as we look, here's our first example, okay? It's an alcohol. So we have CH3OH, okay, methyl alcohol, and it dissolves in water to give us aqueous methyl alcohol. Notice there are no ions here. Here's glucose. Glucose as a liquid, okay? Glucose as a liquid right here. It can dissociate into aqueous, okay? Just glucose dissolved in water. Notice once again, there are no ions. So these molecular compounds are not going to have very high conductivities. The final one we're going to talk about today are molecular acids. These are molecules that can partially or wholly dissociate, depending on their strength. So, as I look at this, here's a strong electrolyte. This is sulfuric acid, H2SO4. It's going to dissociate into hydrogen ion. This is the first dissociation because it has two hydrogens. It will dissociate twice, but the greater value is going to be on that first dissociation. So as you can see, it's going to dissociate into these two ions. Now, this is almost a 100% dissociation. So if I have this acid, it almost 100% dissociates. A weak electrolyte, okay, here is hydrofluoric acid. Okay, hydrofluoric acid is a weak electrolyte. It's going to dissociate into hydrogen ions and fluorine ions, fluoride ions, so to speak. So when we have this weak electrolyte, we signify the weak electrolyte by this double arrow here. So for this lab, you'll see this is just a single arrow. That's a strong, almost 100%, a strong electrolyte. This double arrow, that means that we have less than 100% dissociation, so it's going to be a weak electrolyte. So the double arrow, weak electrolyte, less than 100% dissociation. The single arrow represents a strong electrolyte where we have almost 100% dissociation. Once again, the double arrow tells us that this electrolyte is a weak electrolyte. This is Mr. Braun, ladies and gentlemen, and it has been the pre-lab for properties of a solution, electrolytes and non-electrolytes. Have a great day.